maths question, we're going to look at using velocity time graphs, plotting one, and also using it later on in calculations. So I'm going to start by highlighting all the key information in this question. So it's going from A to B, it's starting from rest, and it moves with an acceleration of 0.6 for 40 seconds long. It then moves at a constant speed before decelerating at a rate of 0.4 to reach point B, and tells you the total distance taken for the whole journey. Now with velocity time graphs, I'm just going to draw a very brief sketch myself. Actually, let's get this straight line tool out, just so it's a little bit more accurate. So we know the general shape is going to accelerate, move at constant speed, and then decelerate. So let's draw that out. It says the initial acceleration has a gradient of 0.6 because remember the gradient of a velocity time graph gives you the acceleration, then moves at constant speed before decelerating with a smaller gradient, so it's going to be more stretched out. Great. So let's label this velocity, this time. You can put the units as well. Time in seconds and velocity in meters per second. Now, like I mentioned before, the acceleration, it tells you the gradient. So if for the first 40 seconds, the gradient is 0.6, we can use that to find the velocity that it reaches when at its maximum speed. We know acceleration is velocity over time. So the velocity, rearranging that, is acceleration multiplied by time. If we take the gradient of 0.6 and multiply by the time taken, that'll give you a speed of 24 meters per second. That's the maximum speed that it reaches. It then moves at that constant speed. It doesn't tell us for how long, so we're not going to label that yet. But since it gives you the rate of deceleration, 0.4, we can once again use that gradient. So we know that A is 0.6 or minus 0.6 because it's a negative gradient, it's decelerating. And we know it's decelerating from 24 meters per second to 0. So we know the change in velocity is 24 or minus 24 because the final velocity take away the initial is minus 24. Perfect. Rearranging this equation, we can find the time taken for the whole journey by saying it's the change in velocity over change in acceleration. Minus 24 over minus 0.6 or 24 over 0.6, which gives you a value of 40. That tells you, sorry, it doesn't, it gives you a value of 60. Let me write that out again. It's because I used minus 0.6 here. It's supposed to be minus 0.4. Sorry about that error. And that's why it'll give you a time of 60 seconds. So the time taken from here to here for the deceleration is 60 seconds. We've almost used everything that it's given us, but it's told us the total distance for the whole journey. Now it's the area under the velocity time graph that gives you the distance or the displacement traveled, because we know that distance is speed multiplied by time. So if you multiply by finding the area under the graph, that's what will give you that. So how we find the total distance traveled, we want to find our own expression. We're going to separate this into three shapes. Let's call this area 1, area 2, area 3. To find the area of area 1, it's simple, it's just base times height divided by 2. 40 times 24 divided by 2. In a calculator, that will give you a value of 480. To find the area of section 2, well, we don't know how long it's traveling at constant speed for, so let's call that length x. We do know that it's gone from 0 to 24 meters per second, so the height of this rectangle is 24, so we call this area 24x. Now to find the area of section 3, which again is a triangle, so we just do the base, which we now know is 60 seconds long, multiplied by the height, which is the maximum velocity that it reaches, 24. We divide that by 2 and that will give you a value of 720. And because it tells you the total distance traveled, 4,000, we can say that the sum of these distance traveled, so 24x plus 480 plus 720. By the way, 480 plus 720, that's 1200. So let's replace this with 1200. And we can say that's all equal to 4,000. Take away 1200 from both sides, so 24x equals 2800. And divide both sides by 24, we get x equals 117 seconds. So this time that it travels at a constant velocity is for 117 seconds. Using that, we can now find the time taken for the whole journey. It's 40 plus 117 plus 60. Great. So it's sort of like a puzzle. You constantly use this equation, you use what you know about the gradient, the area under the graph being the distance traveled, so on and so forth, and you'll find a way through. This will get you 217 meters. And that's the final answer to this question. If you have any questions, please let me know in the comments. Otherwise, thanks for watching. Be sure to like and subscribe. I post a new video every single day. And if you have any tutoring inquiries, just send me an email. I've linked it in the description too.